the sun that hits the earth in one day generates enough energy to power the whole world for a year under current consumption rates. Isn't that unbelievable? If we put solar panels on the south side of every building in the United States, we would meet about 25% of all of our energy needs. 25%. We spend about $1 trillion a year buying fossil fuel from countries, many of which hate us, hate our democratic way of life, do not like who we are and what we stand for, and we're sending $1 trillion to many of those types of countries. Why don't we keep some of that money here on our shores for good, clean jobs that helps our economy, helps employ our citizens? Just makes sense, doesn't it? You can tell I am energized about the potential here. The opportunity on the price point to get that closer to $3 a watt is a technology that's been around about 8 years, and it's called thin film photovoltaic. It's American technology. The #1 country in the world that produces that product is down in Phoenix, called First Solar. Go on the internet and read about that company. It's fantastic from a financial point of view and from an economic and engineering point of view. What that company is doing, they are the leader in the industry worldwide for thin film. Thin film, you know, if you haven't seen that, it's about that thick. You can roll it up almost. The problem with it is it's 8 years old, so a lot of people are a little leery to start putting it on their buildings compared to the crystalline technology that's been around about 50 years. But as soon as these manufacturers of thin film can get insurance companies to put the same kind of warranty on that product that you see on crystalline, I think you'll see a big wave of companies and users, maybe like us, who would jump to that because we've got a 25-year warranty that guarantees that product will last. So that's one of the roadblocks for that thin film technology. The other roadblock is it's about half the efficiency of crystalline solar. So you need about twice as many square feet. What was cool on what we've learned on our meeting houses is because of the way we use our churches, you know, we're using it about 15% of the time, right, during the week. Then it sits vacant. We only needed 156 solar panels. Professor here up front told me that he just put solar panels on his home. How many panels did you say you needed? 30. You needed 30. We only needed 158 to power a stake center 100% of the time, you know, over the course of the year because of how the building is used. And so that helps us in the non-peak times when we're unoccupied mode. We're selling power back to the power grid. So that's kind of fun. That helps to make the business case a little better for our meeting house program. That's not the case on, you know, these kind of buildings, but it does make sense on our churches. So there's a lot of opportunities with this technology. We're developing some tools for our local facility managers to use this technology. Yeah, thank you. Yeah, here's some pictures of the installation. It took 4 days for a crew to get that system installed. If you have a panel that goes bad, which is very, very rare, it takes an hour for a guy to unlock and go in and change out a bad panel. And you can tell through the internet site that we developed with Honeywell to manage the system if we have any outages or problems with any panels. Really the only maintenance you need to worry about on these systems is that inverter on the lower right-hand side. That thing's got a life of about 15, maybe 20 years. And wholesale price, that's about $15,000, $20,000 to replace that inverter. Other than that, it's if it rains, or if it rains, it cleans the panels. If kids try to throw rocks at it, it's pretty tough to damage it. They're very robust.
If you have snow, do you get the...
A week after we put those panels on, we had about 4 inches of snow, and I was there that morning to see. We got no power generation with snow, but within an hour after the sun came up, it slid right off. It's so slick. You know, we've got a 512 pitch on that roof, and it was still a freezing day, but an hour after the sun barely broke through, it all slid off. And we've learned that on cold, sunny days, we actually generate more power than on hot, sunny days. Utah is a great place for solar.
Solar cells are more efficient at lower temperatures.
That's correct. That is correct. So, I'm not going to bore you with some of this stuff, but this is what you saw in the material center. That shows day by day. These are clear days with no clouds, and so you get a nice bell curve. This is clouds. This was a colder day than this day. So, to your point, you can see that and this was in July, July 10th, and going forward, a little bit colder this day, or a little bit hotter this day, and a little bit less power generation. You can see from this right here that we were actually selling power back on the grid at that point in time when we did that screenshot. So we're watching these systems, we're learning more about it, we're excited about the potential. One of the things that I love about solar, you can go ahead. Go back to that one. This is again in the materials center. You can show the youth how many hair dryers you can run on a solar system at that point in time. How many 100-watt light bulbs or toasters or buckets of coal. How much carbon emissions you're saving. And of course dollars. That's things that everybody relates to. We put the screen in the materials center as a tool to train our youth and our families. If you have solar on your building, look what it can do. If you have good practices, no-cost solutions, turn the lights off, being a little careful when you come in and clean the building. Don't turn all the lights on. Turn them on in the rooms that you're in and turn them off. And if you want to see what's happening to the building, you can go in and see when the building's being used for whatever function, the impact of the power being generated on that screen and how it relates to things that people understand. So we're excited about the potential for not only solar, but in this building we've done hundreds of little things to make the building more efficient, to reduce water usage by over 50%, by the way, reduce waste. All the construction material on these buildings didn't go to landfills, it went to get recycled, and I'm talking everything that came off the job site. A lot of them, the new materials we brought in were recycled. You get LEED points for both new materials you bring on that are recycled and recycling the waste that comes off the site. Just hundreds of little things and this is my last thought, because my time is gone. It's the little things that count. And the compilation of a lot of little things mean one big thing, which is a meeting house that you feel good going in, that reduces total cost of ownership, it reduces how much tithing has to be spent to operate that building. You just feel better in those kind of buildings, don't you? I'll leave you with those thoughts, and I'll stay around as long as anyone wants to come up and talk solar or sustainable design or anything else we're working on. Thank you.